Knock on the table in front of you. Go on. Knock on it. Feel how solid it is. It holds your coffee. It holds your elbows. It will be sitting there tomorrow morning in exactly the same spot, whether you are looking at it or not. The world is made of solid stuff. That stuff sits in definite places. It does definite things. And your eyes and your fingertips are telling you the plain, honest truth about every bit of it. That is the most sensible belief a human being has ever held. It built the pyramids. It built every bridge you have ever driven across without a second thought. And it is wrong. Not a little wrong, not wrong around the edges, wrong all the way down to the bottom. I am going to prove that to you, and I am going to do it with nothing fancier than the things already sitting in your kitchen. And I will tell you the strangest part right up front, so you have something to hold on to. The true picture underneath is not just weird. It is weird and exact at the same time. We can check it against the real world to a precision that would make your head swim. Keep that in your pocket. We are going to need it at the very end. Let me first say something in defense of the people who believe the world is exactly what it looks like, because that includes almost everyone who has ever lived, and they were not fools. When you reach for a cup, your hand closes around it. When you drop a plate, it falls and it breaks every single time in the way you expect. Push a door, it swings. The sun comes up. Water runs downhill. The whole world behaves itself so reliably that you would be a lunatic not to trust it. Every machine we have ever built, every wheel and lever and engine, runs on the plain assumption that things are solid, that they stay put, that they do the same thing twice. And that assumption has never once failed an engineer. Your senses have never once let you fall through the floor. So when your senses tell you the floor is solid, why on earth would you argue? Here is why. Take that solid table and imagine I could shrink you down, smaller and smaller, past the dust, past the grain of the wood, down to where the actual building blocks live. We call them atoms. Now I want to tell you what an atom is really like, because everybody has heard the word and almost nobody has felt the shock of it. Picture a great stone cathedral, high ceiling, long aisles, the whole thing silent and echoing. Now put one single fly buzzing in the very center of that cathedral. The fly is the heart of the atom, the nucleus, where nearly all the weight is. And the rest of the atom, the part that takes up all the room, is just a few tiny specks whizzing around somewhere near the outer walls. Between the fly in the middle and the specks near the walls, there is nothing. Not thin air. Air is made of atoms too. I mean nothing. Empty. So how much of that cathedral is actually filled with stuff? Almost none of it. A whisper. And your table is built entirely out of these cathedrals, stacked up by the trillions upon trillions. Which means the table, the good, honest, solid table you just knocked on, is more than 99.99% empty space. You are resting your coffee on a thing that is almost entirely nothing. Now you should be bothered. You should be sitting there thinking that cannot be right, because I just knocked on it and it knocked back. My knuckles did not sail through a cathedral full of empty air. And you are correct. They did not. So we have a genuine puzzle. If the table is almost entirely empty, what on earth stopped your hand? The answer is one of the strangest things I know, and I want you to sit with it. Your hand did not stop because it ran into stuff. Your hand stopped because of a force. Out near the walls of every one of those cathedrals are the electrons. And electrons carry a kind of charge, and charges of the same kind push each other away, hard, the way two magnets shove back when you try to force the wrong ends together. When the electrons in your fingertip get close to the electrons in the table, they shove, violently, long before anything in your hand could ever touch anything in the table. So listen carefully, because this is the first thing your senses have been lying about your whole life. You have never touched anything. Not the table, not your dinner, not another human being, not once. When you shake a hand, The electrons in your skin and the electrons in their skin refuse to meet. And you feel that refusal, that push, and your brain calls it touch. The most intimate thing you can imagine, holding someone's hand, and there is always a gap, a tiny, unbridgeable gap, held open by a force. Solidity is not stuff meeting stuff. Solidity is a force field doing its job so well that you spent your whole life fooled. And if it still nags at you, how can a thing that is almost entirely empty feel so utterly hard? Then think about an ordinary fan. When the blades are still, you can slide your finger right between them into the gaps. There is mostly air in there. But switch the fan on and bring it up to full speed, and now try to push your finger through. You cannot. The blades have not filled in the empty space. They are still mostly gaps. But they are moving and pushing so fast that to your slow, clumsy finger, the whole spinning disk feels like a solid wall. The atoms in your table are like that, only far more so. Almost nothing is in there. But what little is there moves and shoves with such ferocity that your hand meets a barrier it can never break through. Let that settle, and then let me take something else away from you. The color. Look at something red. A tomato, a stop sign, a red coat on a chair. You feel certain the redness is sitting right there on the object, painted onto it, part of what it is. It is not. There is no red in the tomato, there is no red anywhere out there in the world at all. What is really happening is this. White light, the light pouring out of the sun or a lamp, is a mixture. It is like an orchestra, where every instrument is playing at once, every frequency sounding together. When that light lands on the tomato, the skin of the tomato is greedy. It swallows up most of the frequencies and keeps them. But one band, the band we have learned to call red, it cannot keep, so it throws that one back. The tomato is not red. The tomato is everything except red. And it spits the red back at you because that is the one color it could not stomach. That thrown back light flies into your eye, strikes the back of it, and sets off a little signal that runs up a nerve into the dark, wet, silent inside of your skull. And in there, in a place that has never seen a single ray of light in its life, your brain produces the experience we call red. The red is not in the tomato. The red is not even in the light. The red is something your brain cooks up, in the dark, to label which frequency just came in. Turn off the lamp, and the tomato is not sitting there being red in the dark. It is colorless. Color only happens at the instant a frequency of light meets a living eye and a brain that bothers to paint it. The world out there is not colored. The world out there is humming with frequencies, and the color is the private show your head puts on. And while I have the kitchen open, let me take the heat too. You touch a pot on the stove and you say it is hot, and you picture hotness as a kind of substance, some stuff called heat that is soaked into the metal and is now leaking into your hand. There is no such substance. What you call heat is nothing but motion. Every atom in that pot is jiggling, trembling, dancing in place, and the hotter the pot, the more violently they dance. When you touch it, their frantic jiggling slams into the atoms of your skin and sets your atoms jiggling too, and a nerve reports that disturbance, and your brain calls it hot. Heat is not a thing. Heat is a speed. And here is a little proof you can feel for yourself. On a cold morning, touch a metal railing, and then touch the wooden post right beside it. The metal feels far colder than the wood, does it not? But it is not colder. The two of them are sitting in the same air, at the very same temperature. The metal only feels colder because it is greedy. It pulls the warmth out of your hand much faster than the wood can. You are not feeling the temperature of the railing at all. You are feeling how quickly it robs you. Your skin is not a thermometer. It is a very biased reporter, and it has been editorializing to you your whole life. You walked into this lecture certain of three things: that the table is solid, that the tomato is red, and that hot and cold are real things, living inside objects, waiting to be felt. All three are gone. And I have not even reached the strange part yet. Take a breath. Shake your arms out. Because now we leave the comfortable kitchen and we go somewhere that broke the smartest people who ever lived. And I do mean broke them. So far, I have only changed what familiar things are made of. Empty space, forces, frequencies. You can still imagine, if you like, that down underneath it all there are little hard pieces sitting in definite spots, doing definite things whether or not anybody watches. That picture is comforting. It is also false, and the experiment that kills it is so simple you could nearly build it on a rainy afternoon. Take a wall with two narrow slits cut into it, two thin vertical openings side by side. Behind it, put a screen, like a sheet of film that records wherever something lands. And in front of it, you start firing tiny things at the slits. Let us fire electrons, those same specks from the walls of our cathedrals, one at a time. Tick, tick, tick. Each electron leaves the gun, travels to the wall, and if it gets through, it lands on the screen and makes one little dot. Now, what do you expect? You have two slits. Each electron is one tiny thing. It is a lump. So each electron must go through one slit or the other, like a pea thrown at a fence with two gaps. Some peas through the left gap, some through the right, and on the screen behind you should get two little piles. Two stripes, one behind each slit. That is the only sane prediction. Two slits, two stripes. That is not what happens. What you get on the screen after thousands of single electrons have gone through one at a time is not two stripes. It is a whole row of stripes. Bright band, dark band, bright band, dark band, marching across the screen. That pattern has a name. It is the pattern you get from waves. When two sets of ripples cross on the surface of a pond, in some places the crests pile up and the water heaves high, and in other places a crest meets a trough and they flatten each other out and the water goes still. Bright where they add, dark where they cancel. You have seen it in a puddle. You have seen it in a bathtub. It is the unmistakable fingerprint of a wave going through both gaps at once and interfering with itself. But we did not send a wave. We sent one electron. A single, solitary lump. It left the gun by itself. It arrived at the screen by itself and made a single dot. There was never more than one electron in there at a time. So what did it interfere with? Now a clever person makes a guess right here, and it is a good guess, so let us take it seriously. Maybe you say the electrons are bumping into each other. Maybe one electron shoves the next, and all that jostling in the crowd is what builds the stripes. It is a fine idea. And it is already dead, because we already killed it. Remember, we sent them one at a time. One electron leaves, lands, makes its dot, and only then do we load the next. There is never a crowd. There is never a second electron in the room to bump into. Each electron crossed that empty space utterly alone. And still, dot by lonely dot, over thousands of them, the bands of a wave slowly appeared. The pattern was not built by electrons jostling. The pattern was built into each single electron, one at a time. So there is only one honest answer left, and it is insane. The single electron went through both slits at the same time. It went through the left and the right together, as a spread-out wave of possibility. And that wave interfered with itself, and only when it struck the screen did it pull itself together into one dot. A single thing going through two holes at once. Try to picture it. You cannot. Nobody can. I cannot, and I have thought about this as hard as any man alive. Now you do the obvious thing. You say, fine. I refuse to believe an electron goes through two slits at once, so I will catch it in the act. I will put a little detector at each slit, a tiny watchman, so the instant an electron sneaks through a slit, the watchman shouts which one. Now we will see. Now the electron cannot hide. So you switch on the watchman, and you fire your electrons again, one at a time, and the watchmen do their job perfectly. Every single electron is caught going through exactly one slit. Left or right, never both. Good, you think. Sanity restored. But you forgot to look at the screen. You look at the screen. The stripes are gone. The bands of light and dark have vanished, and in their place are two simple piles, two stripes, exactly what you would expect from peas thrown at a fence. The instant you watched which slit, the electron stopped behaving like a spread-out wave and started behaving like a lump. You turn the watchman off. The bands come back. You turn them on. The bands die. Sit in that for a moment, because that is the deepest thing I am going to tell you. Whether the electron goes through one slit or two does not depend only on the electron. It depends on whether you are looking. The act of finding out changes what is true. When nobody checks, the electron explores both paths like a wave. The moment somebody checks, it commits to one, like a thing. Reality, at the very bottom, is doing one thing when it is observed and a different thing when it is not. And do not think this is some side curiosity, a footnote buried in a thick book. This one little experiment, a wall, two slits, a screen, holds the entire mystery of the quantum world inside it. Everything strange about nature down at the bottom is already right there in those slits. If you truly understood in your bones how a single electron can do this, you would understand the whole of it, and nobody does. We have been staring at those two slits for the better part of a century, and they have not given up the secret. And before you ask the question everybody asks, let me answer it honestly, the way I would want it answered for me. People ask, all right, but what is the electron really doing when nobody is looking? Which slit does it really go through? And the honest answer, the answer that took the greatest physicists decades of fighting to swallow, is that the question may not even have an answer. Not because we are too dumb to find it, because nature may simply not keep that fact lying around when nobody measures it. There is no hidden little movie playing backstage that we are forbidden to watch. The movie may not exist at all until the camera turns on. I will tell you what I think is the most honest sentence in all of physics. Nobody understands quantum mechanics. I do not mean nobody has the equations. We have the equations, and they are magnificent, and I am going to brag about them in a minute. I mean, nobody can tell you a comfortable little story in plain human words about what is going on underneath that does not sound like madness. The greatest minds tried for half a century to find the sensible picture hiding behind the strangeness, and they failed, and the strangeness is still there. And do not hear that as a confession that we are stuck. It is the opposite. It is the sound of human beings standing right at the edge of what can be known and refusing to look away. We found a corner of nature so strange that no comfortable story fits it, and instead of flinching, we wrote down the laws anyway. So where does that leave us? It would be easy to walk away thinking the universe is just chaos, that nothing can be known, that it is all a fog. That is exactly the wrong lesson, and now I get to rebuild the world for you, and the rebuilt world is far stranger and far more beautiful than the one you walked in with. Here is what we trade our old common sense for. We give up the idea of little hard pieces sitting in definite spots. In its place, we get this. The fundamental things are not really particles and not really waves. They are spread out clouds of possibility. They do not have a definite position until something forces the question. And we cannot predict exactly what any single one will do. We can only give the odds. Fire one electron, and I cannot tell you where it will land. I can only tell you the chances. Heavier odds here, lighter odds there. Now you might think, well, odds. That sounds like physics has given up. That sounds like a shrug. It is the exact opposite, and this is the part that ought to raise the hair on your arms. The equations that hand out these odds are the most accurate statements human beings have ever made about anything. Let me give you one example so you can feel the size of it. There is a number that describes the magnetism of a single electron. We can calculate it from the theory, sitting at a desk. And we can also walk into a laboratory and measure it directly. And the calculation and the measurement agree to about 1 part in a billion. I want you to understand what that means with your gut and not just your head. Suppose I asked you to measure the distance from where you are sitting all the way to the moon, 250,000 miles across empty space, and I told you that you were allowed to be off by no more than the thickness of a single human hair. That is the kind of agreement we are talking about between the theory and the world. A theory that flatly refuses to tell you which slit the electron went through, a theory built entirely out of odds and possibility, turns around and predicts the real world with that same impossible fineness. Think about what that demands of the universe. For the prediction to come out right to that fineness, nature has to be obeying the rule perfectly, digit after digit after digit, with no cheating, no fudging, no rounding off down where it thinks nobody can see. The strangeness is not sloppiness. The electron may refuse to tell you which slit it took, but it pays its mathematical bills down to the last fraction of a penny every single time without fail. That is the thing I find almost unbearable to sit with. How can one thing be so lawless in what it shows us, and so utterly lawful in what it owes? So here is the new picture, and I want you to hold it gently. The world is not solid. It is mostly empty space held apart by forces, and you have never once touched a thing in your life. The world is not colored. It hums with frequencies, and color is a private painting your brain makes in the dark. And the world at its very bottom is not made of definite little things, doing definite things whether you look or not. It is made of clouds of possibility that only become definite when they are measured, governed by laws so precise they beggar belief, and yet so strange that the people who found them could barely sleep. Now let me tell you why your senses lied to you. Because there is a reason, and the reason is the last surprise. Your eyes and your hands were not built to show you the truth. They were never built for truth. They were built to keep your ancestors alive long enough to have children. A creature that sees the table as solid does not walk off cliffs. A creature that sees the tomato as a bright, separate red thing finds its food faster than the one squinting at frequencies. The cartoon your senses paint for you, the solid, colorful, definite world, is not the real machinery underneath. It is a survival map, a beautifully useful lie. And it worked so well that for almost the entire history of our species, nobody even suspected there was anything underneath it at all. We did not see past it because we were clever. We saw past it because a few stubborn people refused to believe their own eyes. And that brings me to the thought I want to leave sitting in your chest, the one I hope you cannot quite put down tonight. Out of all the things in this universe, all the empty cathedrals and the humming frequencies and the clouds of possibility, one little arrangement of that stuff, sitting on a small wet planet, somehow woke up. It looked at its own survival cartoon, and it got suspicious. It built machines, and it wrote down equations, and it ran the same little experiment over and over, and it caught the universe in the act of being far stranger than it looks. A piece of the cosmos figured out that it had been living inside a cartoon. And then it figured out, to the width of a hair across the distance to the moon, what lay behind the drawing. Think of how unlikely that is. The universe spent billions of years as rock and fire and empty dark, with nobody in it to wonder about anything at all. And then, on one damp little rock, the atoms arranged themselves into something that could turn around and look back at the atoms and ask what they were. The stuff of the world sat up and began to study itself. That may be the strangest fact of all of them, stranger than the slits, stranger than the empty cathedrals, that the cartoon contains, somewhere down inside it, a character who managed to work out that it was a cartoon. The world is not what it seems. It is so much more. So the next time you knock on something solid, I want you to feel the empty cathedrals under your knuckles, and the force holding your hand a hair's breadth away from ever touching. And I want you to ask yourself the question that started all of this. What else am I sure of, right now, that simply is not so? Tell me the one belief about the everyday world you were most certain of before tonight, and whether you still trust it.